Hello, my name is Charmaine Espinosa, and I will be presenting results of some of the experiments we have conducted at the University of Illinois, looking at how conditioning and expansion increase the nutritional value of soybean expellers. Soybean is a legume that belongs to the oilseed crop category and is the most important agricultural protein crop in animal feeding. The oil from soybean is refined for food or industrial uses, whereas the remaining meal portion can be fed to domestic and livestock animals or can be exported to be used in industrial applications. Oil can be removed from soybeans using solvent extraction or the extruder expeller method. If oil is extracted from soybeans via solvent extraction, the resulting co-product is soybean meal, and if oil is extracted from soybeans via the mechanical expeller method, the resulting co-product is soybean expellers. Soybean expellers contain 42 to 43% crude protein, in contrast to conventional soybean meal, which contains approximately 46 to 48%. However, the concentration of fat in soybean expellers is 6 to 8%, and this concentration is greater compared with conventional soybean meal, and this may result in soybean expellers having greater digestibility of amino acids than soybean meal. Soy products contain trypsin inhibitors, which negatively affect the nutrient digestibility, feed efficiency, and health status of the animals. For this reason, heat is usually applied to inactivate trypsin inhibitors and other heat-label anti-nutritional factors to subsequently improve nutrient digestibility in soy products. After extracting the oil from soybeans, the resulting soybean expellers may undergo steam conditioning and expansion, and these processing technologies can inactivate trypsin inhibitors. Therefore, different types and degrees of expansion and conditioning conditions may influence concentrations and digestibility of energy and amino acids in soybean expellers. However, data to demonstrate this are limited. Thus, two experiments were conducted to test the hypothesis that conditioning and expansion increase the standardized ileal digestibility of amino acids, as well as values for digestible energy and metabolizable energy in soybean expellers. Four soybean expellers were used for the two experiments. The first source of soybean expellers, which is the L1 soybean expellers, was produced by removing the oil from soybeans using cold extraction. This source was not further processed, and therefore the L1 soybean expellers is a non-heat treated soybean expellers. The second source of soybean expellers, the L2 soybean expellers, was produced by removing the oil from soybeans using cold extraction, and this is followed by short-term conditioning for 60 seconds at 90 degrees Celsius, followed by expansion at 110 degrees Celsius. L3 soybean expellers was produced via cold extraction of oil from raw soybeans, followed by short-term conditioning for 60 seconds at 90 degrees Celsius, then long-term conditioning for 12 minutes at 100 degrees Celsius, and this is followed by expansion at 110 degrees Celsius. And the last source of soybean expellers, the L4 soybean expellers, was produced by also removing the oil from soybeans via cold extraction, followed by short-term conditioning for 60 seconds at 90 degrees Celsius, long-term conditioning for 48 minutes at 100 degrees Celsius, and expansion at 110 degrees Celsius. Before conducting the two experiments, the four sources of soybean expellers were analyzed for trypsin inhibitors. These graphs shows the trypsin inhibitor activity in four soybean expellers, where the yellow bar represents the L1 soybean expellers, orange the L2 soybean expellers, blue bar L3 soybean expellers, and the red bar represents the L4 soybean expellers. And what we can observe in this graph is that the application of conditioning and expansion was able to reduce the trypsin inhibitor activity from 34 milligrams per gram to 2.4 milligrams per gram. With that in mind, it is our objective to determine how reducing trypsin inhibitors through conditioning and expansion influences nutrient digestibility in soybean expellers. Therefore, the first experiment was designed to determine the standardized ileal digestibility of amino acids in four sources of soybean expellers. 10 growing pigs with an initial body weight of 54 kilograms that had a T cannula installed in a distal ileum were used, and these pigs were housed in individual pens. A total of 5 diets were prepared. Each source of soybean expellers was included in one diet as the only source of amino acids, and a nitrogen-free diet was formulated to measure basal endogenous losses of amino acids. Pigs were allotted to a 5x4 urine square design with 5 diets and 4 periods. 2 pigs were assigned to each diet within each period. Therefore, there were 8 replicate pigs per diet. Each experimental period lasted 7 days. The initial 5 days of each period were considered an adaptation period. Ileal digested samples were collected on day 6 and 7. Moving on with the results, this graph shows the standardized ileal digestibility of lysine, methionine, threonine, and tryptophan in four sources of soybean expellers. Here we can observe the digestibility of indispensable amino acids in non-heat treated soybean expellers, which is the L1 soybean expellers, was less than in heat treated soybean expellers. The digestibility of amino acids in L2 soybean expellers was also less than in L3 or L4 soybean expellers. Same result was observed for the digestibility of branched-chain amino acids, where here we can observe that the digestibility of branched-chain amino acids can be increased by at least 10 percentage units if short-term conditioning and expansion were applied in soybean expellers. However, if short-term conditioning, long-term conditioning, and expansion were applied, the standardized ileal digestibility of amino acids in soybean expellers can be increased by at least 45 percentage units. This indicates that heat treatment is necessary to increase the digestibility of amino acids in soybean expellers. The observation that L2 soybean expellers had reduced amino acid digestibility compared with L3 or L4 soybean expellers indicates that the processing conditions applied in L2 soybean expellers was not efficient to completely ameliorate the negative effect of trypsin inhibitors. Therefore, it appears that long-term conditioning must be applied to completely inactivate trypsin inhibitors and subsequently increase digestibility of amino acids in soybean expellers. Now that we demonstrated that further processing of soybean expellers increases amino acid digestibility, we then wanted to test the hypothesis that conditioning and expansion increase the concentrations of digestible and metabolizable energy in soybean expellers. A corn-based diet and 4 diets containing corn and each source of soybean expellers were formulated. Thus, a total of 5 diets were prepared. 40 barrows with an initial body weight of 17.5 kilograms were randomly allotted to the 5 diets with 8 replicate pigs per diet. Pigs were housed individually in metabolism crates that allow for the total but separate collection of urine and fecal materials. The initial 5 days were considered the adaptation period to the diet, whereas urine and fecal materials were collected during the following 4 days using the marker-to-marker approach. These samples were analyzed for gross energy to enable us to calculate for a parenteral tract digestibility of gross energy, and the concentration of digestible energy and metabolizable energy of each source of soybean expellers were calculated using the difference procedure. Moving on with the results, this graph shows the apparent total tract digestibility of gross energy in 4 sources of soybean expellers. Here we can observe the digestibility of gross energy in non-heat treated soybean expellers was less than in heat-treated soybean expellers, and the digestibility of gross energy in heat-treated soybean expellers was not different. The observed reduction in digestibility of gross energy in non-heat treated soybean expellers also resulted in reduced concentrations of digestible energy and metabolizable energy in non-heat treated soybean expellers compared with heat-treated soybean expellers. To the best of our knowledge, data demonstrating the effect of heat treatment on the energy values in soybean expellers have not been reported. Therefore, they observe energy reduction in the concentrations of digestible energy and metabolizable energy in non-heat treated soybean expellers is most likely due to the presence of heat-label anti-nutritional factors. Trypsin inhibitors has been demonstrated to reduce the availability of digestible amino acids in soybean expellers, which may have subsequently resulted in a reduction in the concentration of digestible and metabolizable energy in non-heat treated soybean expellers. Based on the results from the two experiments, we have demonstrated that the digestible energy and metabolizable energy, as well as the standardized ileal digestibility of amino acids in non-heat treated soybean expellers, were less than in heat treated soybean expellers. This indicates that heat treatment must be applied to increase nutrient availability in soybean expellers. In the first experiment, we also observed that the amino acid digestibility in L2 soybean expellers was less than in L3 or L4 soybean expellers. Thus, the application of short-term conditioning at 90 degrees Celsius is not enough to inactivate trypsin inhibitors in soybean expellers. Therefore, long-term conditioning must be applied to completely inactivate trypsin inhibitors and subsequently increase digestibility of amino acids in soybean expellers. Also, the obtained values for amino acid digestibility, digestible energy, and metabolizable energy were not different between L3 and L4 soybean expellers. Therefore, this indicates that 12 minutes of long-term conditioning at 100 degrees Celsius must be applied to completely inactivate trypsin inhibitors and subsequently maximize the digestibility of energy and amino acids in soybean expellers. We would like to take this opportunity to acknowledge Evonik for their inputs and financial support, and also to the whole team of Stein Monogastric Nutrition Laboratory. Thank you for your interest in this presentation, and if you'd like to know more about other research topics in nutrition, you can always visit our website at nutrition.ansai.illinois.edu. Thank you.